Hi, welcome to the last page of the notes, section 4.4. Now, looking at this differential equation, again, we see that it is a non-homogeneous equation, so therefore we're going to need to find the particular and the complementary solution. So we're going to find the complementary solution first. So we're going to find y sub c. Now, in trying to find y sub c, we are going to go ahead and make all of our y triple prime, y double prime, y prime, and y into m. So we have m cubed minus m squared minus 4m plus 4, and we're going to set that equal to 0. There we go. And looking at this, it looks like I can group the first two and pull out an m squared, and I can group the last two and pull out a negative 4. So I'm going to pull out m squared, and I'm going to get m minus 1 minus, I'm going to pull out negative 4, m minus 1, set that equal to 0. So that both terms have m minus 1, so I'm going to pull out the m minus 1, and I'm going to be left with m squared minus 4 equals 0. After this, I'm going to see that I have a solution at 1 here, and then right here I have 2 solutions. So then I can factor this out more to be m plus 2, m minus 2. So therefore my solutions for m are just 1, negative 2, and 2. So my y sub c is going to be c sub 1 e to the x plus c sub 2 e to the negative 2x plus c sub 3 e to the 2x. Now, seeing that this is my complementary solution, let's look at my particular solution. Now, this question just wants us to find the particular solution, but I needed to find the complementary to see if anything would repeat. So, based off of this, it looks like I have a 5. So what's going to correspond to that term will just be an a for that constant. Now, minus e to the x is going to be minus b e to the x, but I can't just have a b e to the x because I already have a constant with an e to the x. I'm going to have to incorporate an x here. And the same thing is going to be true for the last term. E to the 2x is just going to be c e to the 2x. But again, I already have a constant times an e to the 2x. That should be c sub 3. So then I need to multiply this by an x as well. And so here's my particular solution. So now I need to solve for a, b, and c. So I'm going to go ahead and do y prime of p. The derivative of a is just 0. Taking the derivative here, again, it's going to be another, this is plus, I don't know, I put minus, but it needs to always be plus. So go ahead and taking the derivative, I'm going to get b e to the x plus b x e to the x. The derivative of that derivative here is going to be plus c e to the 2x plus 2c x e to the 2x. So there's my y prime of p. Now to find y double prime of p. Now, in order to save some space, I've already worked this out. So when I do y double prime of p, I'm going to get 2b e to the x plus bx e to the x plus 4c e to the 2x plus 4cx e to the 2x. And then doing y triple prime, so I have to do triple prime because the differential equation is of the third order. I'm going to get 3b e to the x plus bx e to the x plus 12c e to the 2x plus 8cx e to the 2x. All right, and now what I'm going to have to do is I'm going to have to plug in all of this into my differential equation. And so I'm going to go ahead and do that, and I am going to change color just so that you can distinguish between this part and the particular solution. So I'm going to substitute in for y triple prime. So when I substitute in y triple prime, I'm going to get 3b e to the x. Make sure you can see that. Plus bx e to the negative x. Alright. Well, that pen is dying. So bx e to the negative x plus 12c e to the 2x plus 8cx e to the 2x minus all this to b e to the x minus b x e to the x. I'm just distributing the negative, minus 4c e to the 2x minus 4c x e to the 2x. Subtract, multiply everything here by 4, so 4b e to the x minus 4b x e to the x minus 4c e to the 2x minus 8cx e to the 2x. And then add 4 times all of this, so it's going to be plus 4a plus 4bx e to the x plus 4cx e to the 2x. And of course, all of this is going to equal 5 minus e to the x plus e to the 2x. Now, what you're going to see here is that a lot of things are going to be canceling out. And when you cancel out everything, you're going to be left with just 4a minus 3b e to the x plus 4c e to the 2x. And I'm going to set that equal to 5 minus e to the x plus 2. Plus e to the 2x. Now, looking at coefficients, 4a is a constant, and it's going to match the constant over here. So 4a equals 5. Negative 3b is with e to the x, and what is with e to the x over here is negative 1. And for c is with e to the 2x, so what's going to be with e to the 2x is just 1. So solve it and get a is equal to 5 over 4, b is equal to 1/3, and c is equal to 1/4. Therefore, my solution is going to be, or just for the particular, we already have the complementary, but it's just looking for the particular. So y of p is equal to 5/4 plus 1/3 x e to the x plus 1/4 x e to the 2x. I was about to ask if there were any questions, but again, you really can't ask questions right now. Just checking my work real fast. All right, let's move on to the last example. So if you thought that problem was long, this problem is going to match that. So let's look at question 26. Determine the form of a particular solution of the given differential equation. So we have a fourth degree differential equation set equal to 4x plus 2x e to the negative x. And we're just trying to find the particular. But in order to find the particular, we need to find y sub c first. So what I'm going to do is I'm going to go ahead and plug in my m. So I'm m to the fourth minus m squared equals 0. And again, we're able to do this because all of our coefficients of our differentials are constant, 1 and negative 1. So when I solve in this one, what I realized, I can pull out an m squared. And if I do that, what's left is going to be m squared minus 1 equals 0. So this is going to give me 2 zeros at 0. So I'll say m sub 1 is 0, m sub 2 is 0, m sub 3 we'll say is negative 1, and m sub 4 is 1. So that means my complementary solution, y sub c, is equal to c sub 1 e to the 0 plus c sub 2 x e to the 0, because it repeated, plus c sub 3 e to the negative 1 plus c sub 4 e to the 1. And looking at that, it's like I'm just going to have c sub 1 plus c sub 2 x plus c sub 3 e to the negative 1 plus c sub 4 e to the negative 1 x. So we'll just say negative x. And this is going to be e to the x. Alright, now, based off of this, we can find out what our particular solution should be. So y sub p is going to be, looks like what we have here is 4x, so that's a first order linear equation. So what corresponds to that is going to be ax plus b plus, and here we have a first order polynomial times e to the negative x. So that's going to be cx plus d times e to the negative x. Now, when we look at this, we realize, hey, I have a x, a constant times of x, which I have here, and I have a constant there. So I could multiply by x to see if that changes anything, and I'll get an ax squared, but then I have a plus bx, which will go back to the c sub 2x. So I'm going to have to multiply by x squared for this one. That way nothing would repeat. So I'd have ax cubed plus bx squared, and therefore there's nothing that's going to repeat. Same thing over here is going to be true. If I multiply by the e to the negative x, I will get d times e to the negative x, which is going to be a constant. So I need to multiply this by x. And so to look at this, I'm going to change this to plus cx squared plus dx times e to the negative x. It's going to help me out when I do my derivatives. Now, I'm not going to write I'm going to write the derivatives out, but I'm not going to work straight through them. I'm going to show you what you should get after you do the first derivative. So, doing the derivative of ax cubed is going to be 3ax squared. Derivative of bx squared is going to be plus 2bx. And then the derivative of the inside here is going to be, I'm going to keep the parentheses just to, it will help me along the way, 2xc plus d e to the negative x. And then plus, taking the derivative of the outside is going to be negative 1. So I could have a minus 1 here, but I prefer to write negative 1 times cx squared plus dx times e to the negative x. So there's the first derivative. Now let's look at the second derivative. So y double prime of p. When we do the derivative here, it's going to be 6a to the x plus 2b. And then doing the derivative here, I'm going to go ahead and show you what you should end up with. And you should end up with plus 2c e to the negative x plus negative 2 times 2c x plus d e to the negative x plus cx squared plus dx times e to the negative x. And that's just showing where I would have taken the derivative and added a few things, and this is what it would simplify to. Taking the derivative again, I'm going to be getting just 6a. 2b is going to go away. Derivative of that is going to be minus 2c e to the negative x. And Sure. I will go ahead and when I take the derivative again here, I'm going to get another 4 though, so it really is going to be minus 6 c e to the x. Just to not waste so much time in the video. Plus 3 2cx plus d times e to the negative x plus negative 1 cx squared plus dx times e to the negative x. Then doing the fourth derivative, the 6a is going to go away. When I work on this, I'm going to end up with 12 c e to the negative x. Then minus 4 times 2 c to the x plus d e to the negative x plus, and then I'm going to end up with cx squared plus dx times e to the negative x. And so this is what I have for all the derivatives. Now just to plug in. Now it's not going to be too bad to plug in here once we simplify everything. So we're going to plug into y to the fourth, which is 12c e to the negative x minus 4 times 2c x plus d e to the negative x plus cx squared plus dx e to the negative x minus y double prime, which is right here, so 6ax minus 2b minus 2c e to the negative x. This was going to be minus 2, so I could make it just plus 2, so plus 2c the x plus d e to the negative x minus cx squared plus dx times e to the negative x. And that's all going to equal 4x plus 2x e to the negative x. Now I'm going to cancel out what I can, and when I cancel out and when I see what's left, what's going to be left is going to be a minus 6ax plus a 2b. Actually, it should be minus 2b. And then we have, let's see what else will cancel out. So this minus 4, 2cx plus d dx, and that's going to cancel out to where we have minus 2. Distribute the minus 2, it's going to be minus 4 cx e to the negative x. This 12c e dx minus 2 is going to be plus 10c e to the negative x. And the only thing left is going to be this minus 4d and that plus 2. So that's going to end up being minus 2d e to the negative x. And that's all equal to 4x plus 2x e to the negative x. And then we're going to go ahead and simplify. Now, negative 6a is the coefficient of x, so that's going to equal 4. The constant is negative 2b. We don't have a constant over here, so we'll just say it's equal to 0. Minus 4c is the coefficient of x e to the negative x, and the coefficient of x e to the negative x is 2. So negative 4c is equal to 2. And then we have 10c e to the negative x minus 2d. This is actually just 10c minus 2d times e to the negative x. Because it can be written like that, there's a coefficient of 10c minus 2d, and that's going to be equal to, we don't have anything over here for that, and so that is going to equal 0. And now, We go ahead and solve for a. When I look at this, 4 divided by negative 6 reduces to negative 2/3. B is just going to be 0. C is going to be negative 1/2. And then D is going to be, well, we know what C is. C is negative 1/2. So 10 times negative 1/2 is just negative 5 minus 2D equals 0. Add 5, divide by negative 2, and we are going to get negative 5 over 2. And there's our D. So now all we have to do is plug it into our y sub p, which was at the top. And so ax cubed is going to be negative 2/3 x cubed plus bx squared, but b is 0, so we don't need to include that. And then we have minus, I'll say plus, and then inside we have minus 1/2 x squared plus our d, which is another negative 5 over 2 x times e to the negative x. And so we could write this as negative 2/3 x cubed minus 1/2 x squared plus 5 over 2 x e to the negative x. And that's our particular solution. And that's all we need. Alright, I hope y'all enjoyed the video. Sorry this one was so long.